All right, so we're going to tackle this problem task scheduler, also known as least interval. So we're going to solve it using a greedy solution, and there's two ways to solve it. So the first way to solve it is simply say, let's say you have the case A, B, C, D. If you have this case and n is equal to 2, by the way, this is representing a list, you can simply reshuffle it actually. You have, so let's just think about this, A dash dash, the dash represents idle, then A, and you can fill all the other slots with other tasks, sort of like B, C, and D. And this is a valid case, and if you notice, the length, the result of this, the output, the amount of time it takes, is actually equal to the actual length of tasks array. Now let's go on to the second case. So if we look at different cases such as A, B, 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 and let's say we have n is equal to 2, this gets a little bit more complicated because we need to take into account that there has to be 2 idle spots in between. So how can we represent this? Well, we can represent this by going, let's first start thinking by doing this, right? We know the greedy solution would be, we have 2 spaces in between the intervals A, and we have 2 spaces in between interval B. So why don't we first start by actually calculating the number of the idle spaces that we'll actually need. So if we're just discussing this, how many idle spots do we need for task A? Well, we can calculate that by doing, okay, we know we have 2, so we have 2 intervals between each task A. We know the task A shows up 3 times. So we can calculate the number of spaces simply by how many times does A show up, which is 3 times. Subtract that by 1, because remember, we only need to fill up these 2 spaces right here in between those 2 tasks. And finally, multiply that by the number of idle spots that must occur. So we have 2 gaps, 2 idle spots that need to happen. And we also need to multiply that by 2 because that's the number of idle spaces we need in between. So in this case, we have 4 right here. So that's how many spaces we need. Now, finally, we also need to make sure to include the actual A's right here. So we can simply do 3 minus 1 times 2 plus 1, where that plus 1 represents including the 2 A tasks between. So if we do that, that will give us 6. And this 6 basically represents this part of the task scheduler diagram we have so far. So you'll probably notice that we are actually missing the last hanging A. So how do we include that? Well, basically what we'll need to do is we need to include the A at the end, and then I'll also show you how to include the B task. So now that we've calculated the substring, the basic formulation, we basically need to add on the last task, which is a last A task and also the 3 last B tasks. So how do we include that? Well, let me show you something. So if we have A dash dash A dash dash, right? And we also need to include the last hanging A, let me write that in B. So we also need to include also the last B. So what we can actually do is we can realize that B dash dash B dash dash B, and basically the point I'm trying to make here is what we need to add to the end of this substring that we've calculated using the mathematical formula up here is basically 2. So that means there's 2 tasks that show up 3 times. And all we need to do at the end is just add it, because everything before that, the B's can slot right into those idle spots in between. So basically what I'm saying is here, all we need to add is 2, because we have 2 tasks that show up 3 times. So how can we implement this? I think by coding this, it'll actually make it a lot clearer. So let's go ahead and do that. So I'm gonna go ahead and start coding this. So what can we do to keep track of the number of times those tasks show up? Well, we can actually use default dict. We can use counts is equal to default dict int. And basically after we do that, we can go through the number of tasks and increment it. So we can go for t in tasks and basically say counts t plus equals 1. So we can basically keep track of the number of tasks that show up. Then after that, we can simply do after getting the counts of all the elements, all we need to do is separate list, story count. So what we're getting here is a list of the counts of the tasks that appear, and we're storing it in a list, and it's going to be sorted from least to greatest. And what we're going to do next is we're basically going to, where the last item in the list represents the max number of tasks. So we're going to also initialize a counter variable. A counter is going to represent that the additional A and B tasks that we have to add on at the end. And basically what we can do is we can say, okay, while we still have a list of values and we have the last item in the list equal to the max number, all we have to do is pop the last item off the list and increment counter. And finally, we have this one case where we calculate it, where we have the max number minus 1, as I described right here. Max number of tasks, so how many times do we need to add, how many idle spaces do we need to add, times n plus 1, representing the two A's we also have to add in between those two idle spots. And finally, add a counter to it, where we represent the last A and B that we're adding on. And finally, remember how I said we could also have the case where it's the actual length of the task, where we can just shuffle it in between? Well, we can simply say there's two cases that return either the max of length tasks or the second case return this calculated formula for fitting in between. And those are our two cases, and let me just run it to make sure that everything is right, and go ahead and submit. And there you go. That's one way of solving the task scheduler in a greedy solution. And I hope this sort of highlights the intuition behind it. Feel free to leave a comment if you're still confused. I'll try to get back.